Hello, everybody, and welcome to another episode of Tech Talk. Today is going to be another day closer to watching Mark Edworthy's head explode. We have we have been debating on how long it's going to take for this to happen, but I do believe that it's coming close because today's topic is yet again about freaking artificial intelligence, as he hates to
Yay,
hear it being referred to.
yay,
Specifically,
yay.
what we're going to do is we're going to get more into the linguistics area of what we were talking about. Now, there was a lot of things that we did discuss, and then I went through and browsed over some keywords that were important to all this. And I want to focus on that and not go back over all the crazy stuff that we had already discussed before because um, Mark and
You, you would just make me cry.
yeah.
Yeah. It would make me very, very sad if we did that.
Now, not only that, but Mark is a very, very dear friend of mine, so I don't really want to see his head explode, to
Okay.
be honest. I just don't. I don't want to see that. So with that, I guess the best way to do it to open this all up is to go ahead and just make the reading. And if anything sticks out to you that you want to make a comment on, make a comment, okay? And I'll stop the reading, mark where I left off or where I stopped at, and then continue from that point on. Sound like a plan, Mark?
Yeah, carry on.
Okay.
Yeah.
So, first, I want to start out, like I said, in linguistics and start out with tokenization. Now, tokenization is a fundamental process in linguistics and natural language processing that involves breaking down text into smaller, manageable units called tokens. These tokens typically represent words, but depending on the approach or model, they can also include subwords, characters, punctuation marks, or even word pieces. The purpose of tokenization is to transform raw text into a structured format that computational models can process, analyze, and learn from. In traditional linguistic terms, tokenization is the first step in parsing language. It separates a continuous stream of text into distinct elements, allowing for syntactic and semantic analysis. For instance, the sentence "the dog barked loudly" would be tokenized into "the dog barked" and "loudly." Now, this step is essential because most natural language tasks, such as part of speech tagging, named entity recognition, and sentiment analysis, depend on understanding individual elements of a sentence. Now, in modern computational linguistics, especially within large language models, tokenization can become more complex. Many contemporary models use what is called subword tokenization, which allows for the breaking of rare or unknown words into smaller known components. For example, a word like unhappiness might be split into unhappy with an I and ness with NESS. This technique helps models handle large vocabularies with fewer out of vocabulary issues, as they can still process part of words they have seen during training. Now, byte pair encoding, which is BPE, and WordPiece are two popular subword tokenization methods used in models like GPT and BERT, which I've never heard of BERT before, respectively. Now, tokenization can also be sensitive to punctuation and spacing. In a language where words are clearly separated by spaces, like English, tokenization is relatively straightforward. However, in languages like Chinese or Japanese, where words are not separated by spaces, more advanced segmentation algorithms are needed to accurately identify word boundaries. From a computational perspective, tokenization also serves as a bridge between the human language and machine reading input. Each token is usually converted into a numerical representation, such as an index in a vocabulary or a vector in an embedded space. Now, these numerical tokens are what the model actually uses to perform computation. Tokenization is related to, but distinct from, part of speech tagging. While tokenization breaks down a sentence into smaller units, which are tokens, part of speech tagging assigns grammatical labels to each of those tokens, identifying their syntactic roles within the sentence. Both processes are fundamental in natural language processing, but they serve different purposes and occur at different stages in a language analysis pipeline or analysis pipeline. Now, part of speech tagging, also known as POS tagging or grammatical tagging, is the process of identifying and labeling each word in a sentence with its corresponding part of speech, such as noun, verb, adjective, adverb, pronoun, proposition, conjunction, and interjection. Now, these tags may also include more specific classifications like singular, plural nouns, verb tense, and comparative or superlative adjectives. POS tagging provides valuable information for downstream tasks like syntactic parsing, semantic analysis, machine translation, and question answering. It helps clarify the structure of a sentence and resolve ambiguities. For instance, the word book could be a noun, I read a book, or a verb, please book a room. POS tagging uses context and often statistical or machine learning models to determine the most likely tag for each word in a given sentence. Several methods exist for performing POS tagging. Rule-based taggers use predefined grammatical rules, while stochastic or probabilistic taggers use statistical models like hidden Markov models to predict tags based on the likelihood of word tagging sequences. More advanced approaches use machine learning, including neural networks, to learn tagging patterns from large annotated corpora. Tokenization breaks text into units that are meaningful to the model, while part of speech tagging adds a layer of grammatical understanding by labeling each token with its role in the sentence. POS tagging is not a part of tokenization, but follows it as a separate and crucial step in the process of understanding language structure. Now, after that, it goes into sentiment, okay, which is sentiment analysis. Now, that is a subfield of natural language processes that involves determining the emotional tone or subjective meaning behind a piece of text. The goal is to identify whether a given expression conveys a positive, negative, or neutral sentiment. It, in some advanced applications, sentiment analysis can also detect specific emotional states such as joy, anger, sadness, or sarcasm, where it might assess the strength or intensity of the sentiment. Now, the process begins with text that has usually been tokenized and annotated, either manually or through automated processing. After breaking the text into manageable units such as words or phrases, the system uses linguistics, statistics, or machine learning techniques to interpret meaning based on context and word usage. Earlier approaches to sentiment analysis relied on lexicons, lists of words that carry known sentiment values. For example, words like great, happy, or love might carry positive weight, while words like terrible, angry, or hate might carry negative ones. Now, these words level evaluations are aggregated to infer that the overall sentiment of the entire sentence, paragraph, or document. However, language is often nuanced, and sentiment is not always expressed through overtly emotional words. For that reason, modern sentiment analysis systems frequently use supervised learning models that are trained on large corpora of labeled data. These models learn patterns and associations in language that go beyond individual words and include syntax, idioms, negations, and even domain-specific expressions. For example, a phrase like "not bad" might imply positivity despite containing a negative word. Similarly, "I guess it was okay" might carry a mild or ambivalent sentiment that requires context to properly evaluate. Some systems take it further by incorporating deep learning architectures such as recurrent neural networks or transformers to capture long-range dependencies and settle contextual cues in language. These models are capable of understanding more sophisticated linguistic constructions, figurative language, and the relationship between words across longer passages of text. Sentiment analysis is widely used in a range of applications. In business and marketing, companies monitor social media, product reviews, and customer feedback to understand public perception of brands or services. In in finance, sentiment analysis is used to gauge market mood by analyzing news articles, reports, and investor commentary. In politics, analysts might access public reaction to speeches, debates, or police sentiment or policy announcements. It also plays a role in mental health applications where sentiment analysis of written or spoken language can help detect patterns of distress or mood fluctuations over time. Despite its usefulness, sentiment analysis still faces challenges. Sarcasm, irony, cultural idioms, and emotional neutral languages or language with loaded implications can be difficult to interpret correctly. Moreover, the sentiment associated with a word or phrase can change depending on context. As a result, accuracy and reliability depend on the quality of the training data, the sophistication of the model, and how well it adapts to the specific domain or audience. Sentiment analysis is a powerful tool for interpreting subjective language. It provides insights into emotional tone, opinion, and social mood across a wide array of text-based media. Its effectiveness depends not only on linguistics processing, but also on context awareness and the ability to model human subtlety in communication. Now, emotional tone refers to the effective quality or mood conveyed through languages, and it plays a role in how communication is interpreted by both humans and machines. Now, in natural language, emotional tone reflects the speaker or writer's underlying feelings, attitudes, or psychological state. This may be consciously expressed or unconsciously implied through choice of words, sentence structure, rhythm, and context. Recognizing emotional tone allows systems such as sentiment analyzers, conversational agents, or customer service bots to respond in a more sensitive, intelligent, and human-like way. Emotional tone is broader than just positive or negative sentiment. It accompanies a spectrum of emotions such as happiness, sadness, anger, fear, surprise, disgust, pride, and embarrassment. While traditional sentiment analysis might classify a message as simply positive, negative, or neutral, emotional tone detection seeks to identify the specific emotional category being conveyed. For example, the phrase "I'm thrilled with the results" and "I'm furious about what happened" both have strong emotional tones, but they represent opposite ends of the emotional spectrum, joy and anger, respectively. Detecting emotional tone involves analyzing not only the words themselves, but also how they are used in context. Tone can be affected by modifiers, intensifiers, and syntactic constructions. For example, exclamation marks can intensify excitement or urgency, while ellipses might suggest hesitation, uncertainty, or subdued tone. The phrase "well, what was something" could imply sarcasm, resignation, or disappointment, depending on the surrounding context. Recognizing emotional tone requires the ability to interpret both literal content and nuances of delivery. Modern computational systems often approach emotional tone analysis using machine learning and deep learning techniques trained on large datasets annotated for emotional content. These models are designed to pick up on linguistic cues such as emotional charged words, figurative language, emoticons, or even punctuation patterns. More sophisticated systems might use attention mechanisms or context embedding to grasp subtle shifts in tone across longer passages of context or conversation. Voice-based systems add another dimension to emotional tone detection. In speech, tone is conveyed through prosody variations in pitch, volume, speed, and rhythm. An emotionally intelligent voice assistant or virtual agent can analyze the user's vocal tone to adjust its own responses, making interactions feel more personalized and empathetic. For instance, a soft, calm voice might be used in response to stress or sadness, while a more upbeat tone might be used in cheerful context. Emotional tone analysis is valuable in many domains in customer service. Understanding a caller's tone can help prioritize urgent or emotional charged issues. In education, tone analysis can monitor student engagement or emotional well being. In mental health applications, shifts in emotional tone across messages or journal entries can provide early indicators of psychological distress. It is also used in social media monitoring, marketing, and public opinion tracking, where understanding tone helps reveal the emotional context of public discourse. However, accurately interpreting emotional tone remains a challenge. Emotions are complex, culturally influenced, and often expressed indirectly. Yeah, sarcasm, irony, and humor can distort literal meaning. Furthermore, for some people may mask their true emotional tones deliberately, or express mixed emotions that are hard to categorize. For computational models to handle emotional tones effectively, they must be able to combine linguistics, contextual, and even behavioral information to approach the richness of human emotion handling. Now, right there, I wanted to stop because there's two things that I relate to on this, and one of them is the fact that in the past I've had times where I've used uh, text to speech narrators to go through and use the narrators for a voice. And I had to go through and manually listen to them so that I could change the words around sometimes to where it would sound more human like, you know. And for me, I noticed that when you go on the internet and you watch videos with narrations, people don't usually do that. They just usually have it playing through and it sounds synthetic, like you know that it's freaking a drone or a robot or whatever. Sounds like it at least. You know, I know that mine doesn't make it as human like, but at least it comes closer, you know. When I was doing that narration for John G on Minds, that's what I did. I went through and I made sure that the words, oh, I didn't edit the words, but I went through the actual recording and I made sure it sounded as close to human as possible. That was one thing that stuck out to me. And then another thing that this really sticks out to me about is there was a TV series. It might still be out, but I'm not sure. But it's named Bull. And it's about a guy who uses this kind of technology in courtrooms so that freaking he can analyze uh, the behavior patterns and the attitudes of people in the jury so that he could determine which ones would be best to put on the jury for trial. You know, um, that is something that really stuck out to me when I was reading through that. So um, I'm gonna stop that right there, and then maybe we can go on further if you want to say something, Mark.
Uh, you, you're just talking about linguistics as a general sort of concept, more than anything to do.
No, actually, this has something to
Um,
do with it. Like you keep bringing that up and everything, but like this is actually what we've been talking about. This is a part of computer
yeah,
analysis,
but it's also part of human speech.
right?
More just because something is associated with a computer doesn't mean it originates or it's it, eh, people who write books use linguistic structure. People who talk out in the streets use linguistic structure. You just
Everything that I just freaking read has to do with how computers deal with linguistics. You see?
I would say that's how humans deal with linguistics.
No, they don't. This
No,
is
what?
this is a complex. This is a complex freaking way of dealing with linguistics and computers. Okay, they don't teach this to people who are trying to learn linguistics. They don't. They teach the concepts of this, but this goes deep into it. Okay, they're
So so
trying to teach. They're teaching computers how to freaking hear what a person's tone is, so that they can determine if freaking they are being freaking subjective or critical or anything like that. Literally teaching a computer how to freaking tell what a person's tone and their emotions are.
uh,
Okay, I mean that's pretty intense. Okay, and I said it before the stream before I started the point where I'm going to turn this into a video, and I'll say it again. Okay, this is going to become a privacy issue. I just mentioned a show where freaking that I'm going to find out more on it, but I think freaking this can be used in courtrooms. Okay, because this is exactly what they're talking about when it comes to freaking that show, where they are freaking listening to people and going off of their behaviors and the tone of their voice to find out if they want them on the freaking jury or not.
yeah, but wouldn't a lawyer in the
I don't know. That's the thing. If it's true, then they can do that kind of stuff, um, and they could
well, they
also
don't need a computer to do that. You just need an understanding of the language you speak and
the
ears.
computer. No, the computer itself can do it without any human assistance. So
But what's the
whenever
point? So now you're just saying, fire all translators and stick computers in their place.
that's not what
You
I'm
don't
saying.
a massive help for
That's what
the
this is saying.
economy.
That's what this is saying.
Uh,
Yeah, that's what this is about, man. Why should we
okay.
have all those translators and all those linguistics or experts on there? We can just put AI in there to take its place, and then it's
Oh,
gonna
AI, not natural language processing isn't
yeah
AI. I would
natural
argue,
yeah
and I have argued on many occasions.
machine learning and stuff of that nature. You
Uh,
know. Now the one thing too is it's like I'm wondering if because I don't know how well I know that with the Chat GPT there are narrators on there. I'm not really any more impressed with them than what uh, I am with like using freaking Notebook. You know, on Microsoft. So I've used both of them, and to be honest, I've never found anything that was actually impressive, even with the AI version of it. Now I don't know for sure if Notebook itself is AI or if it's just uh,
Outlook, so I'm not familiar with the product.
oh, it's Microsoft. It's where you can go in and put your well, like me, I take my notes and I put it on Notebook, and then I can use a freaking uh, narrator to go through and read it out loud.
Uh,
But that's what.
Hello, guys.
Hey, Tan, how you doing today?
Doing all right. I'm still catching up on some work, but I thought I'd just join to listen in at least.
Okay. Have you ever heard of a TV series called Bull?
What is it?
yes.
Bull, Bull.
Bull. No.
The guy that used to play on NCIS, the young one, that always got his head slapped in the back of his head. I forgot his name, but he played on it, and what he his job was on the show was they would have the lawyer that went in to do the case, but he would have an entire team that would go in and analyze the jury members to freaking with computer technology to determine which ones um, would be acceptable for the juries on the jury. And from
It's
the from
Dr. Jason Bowl.
yeah,
It's a fairly new series. Huh? Started in 2016.
yeah, well, that's not fairly new,
Yeah,
you know.
old would be like from 1980s.
Yeah, yeah. Well, but from the stuff that I had just read, man, that's exactly what I was getting from it. That they've got this program where it's set up and it can listen to your voice and it can tell what tone your voice is. It's supposed to also try to detect emotions and things of that nature, um, and tokenization and things. I don't know if you've gotten into any of that before and what that entails. But
Tokenization.
yeah, and sentiment analysis, things like
Are you
that.
talking about the same kind of process as in like those deep learning algorithms?
Yes, yes,
Yeah.
that's exactly what it is. Now, Mark came close to having his head explode because he seems to feel that this is nothing more than linguistics, and it has absolutely nothing to do with computers.
I didn't say I shouldn't go into computers, but the sort of things that you were talking about, we've been doing for hundreds, thousands of years.
But it's doing it faster. It's actually doing it in real time while freaking the discussion
Real
is
time.
taking place.
I know what is real time. I mean, I'm doing it to you now.
If I had the program,
Talking to you in real time.
if I had the program set up right now, I would know exactly when your head was about to explode. Just saying. I mean, it is that freaking technical. This stuff is doing it in real time. You know,
Okay,
and
you
that's
got
what
it
makes
about
it.
real time.
Now you know as well as I do, and I don't understand why you don't understand this or you don't want to understand it. But freaking, computers run way faster than we do. Okay, so
Just
so
because something runs faster doesn't mean it's of use or interest or people. Just because something moves faster doesn't mean.
yes, it does. It does. It means quite a bit of it. I mean, it's very important. You know, I mean, I so. What do you think about all that, Tan?
Uh, Sorry. Well, what are you talking about again?
He he uh he doesn't think that the fact that it runs faster it's an important issue. That
Like
the
the algorithms runs
Well,
faster?
I rephrase that. It's not an essential issue.
I think it really is a potential issue. This is more and more of this is actually going to
Essential.
lead down to privacy issues. I seriously do see
Okay.
that coming. Um, you know, we went through a lot of stuff before, which you didn't seem to find of interest. You thought that it was just linguistics, but this is computer learning. This is stuff that's a part of it. You know what I mean? And it amazes me too because
But,
you're real big
what
on
I'm
privacy.
arguing is are you separated each of those elements? That's no more different than how humans are taught how to speak their language and sentence
That's
structure and
Well, that is pretty significant that they're teaching this stuff to a computer now. Okay. Now, I mean, okay, they're teaching us. Okay, they've been teaching us this stuff, but the fact that a computer is learning this stuff and actually doing it, okay, they're taking and they're literally freaking duplicating the human mind and simulating it. And you don't think that that's even closely to amazing? It doesn't have to be real. It's the fact that they are simulating it.
okay, I'm not sure if teaching and learning the concept of computers are the correct terms. But yeah, it's just a simulation.
Well, you were talking before about these NCUs, okay, um, and that's one thing that I do want to get into more of. I think we kind of tapped on it the last time we were talking about it.
Uh,
Um, Now, deep learning uses freaking GPUs to simulate.
well, some of it, some deep learning frameworks do. Some
And then you brought in the NCUs, which are the
NPUs, natural language processing unit.
now that's not simulation. That's what's so amazing about that. So um, it's really interesting how that works out because like this is going from a simulation to actually programs that's real time. You know what I mean? Because we know the difference between what a simulation is and what freaking I use simulator games. You know what I mean on video gaming. So not only that, but freaking I used VirtualBox too when I was on Linux. I know exactly what that's all about. There is a difference between simulation and what's really going on in the computer. So that right there is something that really does spark my attention. You know, does that make you guys can
Yeah,
still hear me, right?
yeah.
Yes,
We're following you.
still listening, but
Yeah. I was reading and it got to the point where it was talking about freaking detecting emotional tone. It can actually they're coming up with emotional tones in these programs where they can actually detect what the mood is of a person when they're talking. So, like, we're having this conversation. If we had that program set up, it could tell us exactly what your emotions are by the way you're talking. I find that really interesting.
Mm.
And that's that's the thing that really gets me about all this stuff. I mean, these programs, I should say, or algorithms, or whatever you want to call them. They're actually doing this, and they're they're really getting complex. It might not be freaking, you know, what you're thinking of as intelligence or nothing, but it is significant. It's nothing that you just turn a blind eye to. You know,
So how is this going to affect our daily general lives?
it will. Okay, if you get in trouble,
And give us examples.
you like sitting on this internet having a conversation, right? Now,
Mm.
what if you turn around and you get introduced to a new program that's put on on all these platforms that listens to your every word, and when you freaking start acting inappropriately according to the tone of your voice, you're kicked off. You're gone.
I wouldn't be using those platforms,
What
but
if
I'm somebody who reads the agreement.
you know? I mean, this stuff is becoming mainstream. It's going to be it's going to be in everything that
Everything.
yeah. they, I was talking the other day about Windows 11 and the messed up stuff that they're doing. Now they're forcing stuff onto us without actually us allowing it. Okay, like, and then they put things on the freaking the program that's on by default. So you have to go through and you have to make sure that
They're not forcing you to do anything. Either you want to use the product and purchase the product, or you don't want to use the product.
I mean, the thing of it is when you use it, you should be given the information. Now, this brings me back to what I was talking about before. Like, when it comes to privacy issues and what we're discussing here, you don't seem to think that it's important, but you're big on, terms of service and people's privacy and stuff. But you don't understand how this is actually going to be very, very serious when it comes to people's privacy and the terms of services and things of that nature. You know what I mean? They're going to be implementing this stuff into everything.
Not everything.
You watch, I guarantee you, they're already talking about putting these into bots for customer services, and it's
Yeah,
a,
yeah, in just certain products. Yeah, you're gonna have that in certain products, but you still want certain customers still will want that human um, communication. As an example, why do you think people go to use clothes tailors rather than sending their clothes um, through postal services to get their clothes tailored?
they're already doing it according to apps.
Yeah, but
I mean, you're so
you can
1980.
still go to your local tailor and actually have a human contact.
You're so 1980s. I swear. Like they're doing that on the internet now, dude. Like
Yeah,
that's
but you as the consumer have got the choice to use them or not.
okay. And what?
And
How many people are going to use that app to freaking get their clothes sent to them through the mail? And how
well,
many?
I'm just saying that there will be uh, more. There are more discerning people out there.
There's not very many. We both know that. I mean, how many other streams outside of TikTok have we been on where people don't freaking really discern? They don't really care. They just want to freaking get what they want when they want it and how they want it. Like the average person doesn't
Yeah,
think.
how they want it. If they want good customer service, they'll go to human.
Oh, I don't know. Do you?
Or if they want excellent customer service, they'll go to human.
Well, I mean that all sounds fine and dandy if you're living in the 1980s, but that's not the way people do it. They do most of their
So,
shopping.
are you saying that every single business out there, no matter how big or how small they are going to replace their entire advertising, marketing, PR companies or departments with machines?
Okay, let me throw it to you like this. How many companies and corporations do you think freaking had Windows XP as a program for their companies?
I
Well,
know quite a few. I can think of quite a few, especially in the banking sector, actually.
mhm. So I remember when they switched freaking Windows XP out, man. It literally caused a freaking slowdown on a lot of companies. The place I worked for, I was a fry cook, and to clock in and out, you had to freaking clock in and out on a Windows XP program. And
The two major operating system deployments I've done, one related to a college that I was working for. I was the only person available in the department at the time.
he froze up.
Machines in 3 weeks. And also that was from 3.11 to 95, and then I did something like a 4,000 machine from 98 to XP in an insurance company.
Yeah. Now, you remember when they switched Windows XP out, right? To, what was it, Windows 7, I believe it was?
Well, depending on where you are, you could say Vista ME, you could say
Well,
2000.
Vista was out at the same time as XP was, if not. But
No, no. There are a couple of years between the first edition of XP and Windows Vista.
Mhm. Okay, so I am going to finish off this reading, and after that, we can go on to some other stuff after that. But this one, I'll just read it out. If you have anything that you want to say, you don't. But I just want to get it on to the video so that frickin' we at least have this information out. We started this, and this is all of it in a nutshell. So um, let me go ahead and do the second part of it and get it taken care of, and we'll be done with it. Because there is some important stuff. Um, Let me figure out where the hell I'm at now. You distracted me with your subversive ways. You
My,
subversive.
my subversive linguistics.
Devil man, devil man, devil man, devil man. Okay, so now I want to talk about entity recognition, which is more formally known as named entity recognition, or NER. It's a key task in natural language processing that involves identifying and classifying specific pieces of information within a body of text. Now, these pieces of information or entities typically refer to real world objects such as people, organizations, locations, dates, quantities, and other definable terms. The purpose of entity recognition is to make unstructured text more structured and meaningful by labeling and categorizing elements that carry significant semantic content. When a system performs entity recognition, it processes a sentence or document and attempts to locate words or phrases that constitute named entities. For example, in the sentence, Barack Obama was born in Hawaii and served as President of the United States, a well functioned NER system might identify Barack Obama as a person, Hawaii as a location, and President of the United States as a title or role associated with an organization or government entity. These labels help transform raw text into structured data that can be used for indexing, querying, summarizing, and decision making. Entity recognition typically works in several steps. First, the text is tokenized, breaking it into individual units like words or punctuation marks. Then, linguistic features such as part of speech, tags, or word shapes, capitalization or numbers, etc., are analyzed to help identify potential entities. Finally, machine learning or rule based models classify those segments based on their context and meaning. Most modern systems use supervised learning, where a model is trained on large data sets, annotating with examples of entity types so it can learn patterns and make accurate predictions on new, unseen data. There are various categories of named entities, and while early NER systems focused mostly on people, places, and organization, modern systems have expanded to include dates, times, monetary value, percentages, product names, artistic works, medical terms, and many other specialized domains. For instance, the biomedical research entity recognize, rec- recognition might be used to identify genes, proteins, disease, or drugs within scientific articles. NER plays a crucial role in many practical applications in search engines. Recognizing entities helps improve query understanding and retrieve more relevant results. In customer service, recognized names, account names, and locations help tailor responses to individual users. In journalism and media monitoring, entity recognition enables the automatic tagging and linking of key subjects across articles. It also supports information extraction from legal, medical, and technical documents, allowing software to sort, categorize, and cross reference complex bodies of text with greater efficiency. One challenge to entity recognition is ambiguity. Words or phrases may refer to different entities depending on context. For example, apple could refer to a fruit or a technology company. NER systems need context awareness to make the correct distinction. Another issue is variability in how entities are expressed, especially with abbreviations, nicknames, or multilingual references. Robust NER systems must be capable of adapting to these variations and maintaining high accuracy across different types of text and domains. Named entity recognition systems identify proper names and places by analyzing the structure, context, and statistical patterns of language. At its core, the process involves several steps that combine linguistic rules, machine learning models, and large annotated datasets to recognize when a particular sequence of words is referring to a real world entity like a person or a location. The ability to distinguish proper names and places depending on both surface features of the word and their contextual relationship within sentences. To begin with, proper names and place names typically follow distinct orthographic patterns. Many of them are capitalized in language like English, which gives an initial cue to the system. A sentence like Michelle Obama visited Paris in 2019 immediately signals three possible entities. Michelle Obama is likely a person, Paris is likely a location, and 2019 is likely a temporal reference. Capitalization along with word space, such as combination of capitals and lowercase letters, give the system its first indication that a name entity is that a named entity may be present. The NER system relies on contextual clues. For example, if a word like Paris appears near travel related verbs like visited, flow to, or stayed in, it reinforces the interpretation of Paris as a geological location. Similarly, Michelle Obama occurring near titles like First Lady or verbs such as spoke or wrote might reinforce her identity as a person. In cases where capitalization alone isn't enough, such as in all lowercase text or when names resemble common nouns, context becomes vital in disambiguating meaning. Machine learning models, especially those trained on annotated corpora, play a major role in improving identification accuracy. These models learn from thousands on millions of examples where people, locations, organizations, and other entities have been manually labeled. Over time, they learn patterns on how proper names are constructed and used. For instance, a sentence like University of California, Berkeley might be labeled as a single organization entity, even though it contains multiple capitalized words. The model learns to recognize these patterns as a coherent unit based on how such names commonly appear in training data. NER systems also use part of speech tagging to help distinguish names from other word types. A sequence like John runs every morning would see John tagged as a proper noun and runs as a verb, reinforcing the interpretation of John as a person. Similarly, the phrase Mount Everest is in Asia benefits from recognizing Mount as a clue that the next word is likely a geographical location. Now, some systems use gazetteers, large lists of known names and places, as a reference. This allows the model to check if a given word sequence matches a known entry. This is especially useful for uncommon or ambiguous names. However, relying too heavily on gazetteers can cause problems when encountering new or unseen names, which is why modern systems balance such lists with contextual and statistical learning methods. There are also complications in identifying names and places correctly. For example, a name like Washington would refer to a person, George Washington, a state, Washington State, or a U.S. capital, Washington, D.C., depending on context. Disambiguating some names require understanding the surrounding words and sentence structure. In multilingual settings or in informal language such as social media, sparing variations, nicknames, or missing capitalization make the task even more complex. In advanced systems, especially those based on deep learning models like transformers, understanding the semantic context of a name goes even deeper. These models look at word embeddings, where each word is represented in a high dimensional space based on its meaning. Through training, the model learns that London, Paris, and New York often appear in similar contexts and therefore share spatially proximity in embedding space, which helps the model generalize to other locations it hasn't seen before. Proper names and places are identified in text through a combination of linguistic patterns, contextual understanding, machine learning, and external knowledge bases. Named entities recognition systems have grown increasingly sophisticated and are now capable of parsing complex nuances and ambiguous uses of language to extract meaningful references to people and places in both structural and unstructural text. Now, for me, um, to me, that is just straight up freaking monitoring. Okay, these people, to me, Seems like they're wanting to figure out your location. They're wanting to know what you're talking about. Everything. This could be potentially freaking dangerous, in my opinion. If you actually listen to what was being said there, that's very very dangerous. Um, that's that's freaking spying.
It's the technology. It's just one way of understanding what's being spoken or what's being written. I mean, it's how you use it is the danger.
Hmm.
But you were reading about how NRE compares to transformer model. Um, how do you how is it different from the transformer architecture like the one used by ChatGPT?
Well, with what I've been finding out is with they're trying to get away from using the transformer models, and they're trying to make it to where it's more autonomous. That's one thing that we were talking about in the last episode. But then right here, they start talking about they don't want to rely on it too much because they're using it for data sets to where they can, like with Washington, when it was using the word Washington, it could refer to Washington State. Well, no, it was England, London, Paris, and all that. They have it set up already where they can already distinguish that this is a location. You know what I mean? So they don't have to go through the whole process. Like,
But isn't NRE an older uh, technology, older concept? Like transformer architecture would be the newer thing. Like
from
this NER is like 1990s technology.
now, from what I found out, it's still being used. Like, this is something that they haven't been able to develop beyond. You know what I mean? It's this is
Well,
something.
Roger, you are making it sound like that these what you call they are a single entity or a single organization, or there is some sort of unwritten rule that you're saying you must only use this specific technology principle, not this technology principle. Who are they?
Well, it most likely be your former employees
Employers.
or
My
employers. Employers.
point is that there is different products out there, and people buy um, using different techniques.
You know, all those people that you work for, that you were getting those contracts from. Those are the people who are they. They're going to use this technology so that they can profit off of people like
Not
me.
necessarily. Again, you're expecting everybody to buy off a one vendor.
No, they're all going to do it because this is going to be the end thing. It's going to be.
Not all.
It already is the end thing. It's cool. You're not cool if you don't
Okay, if
have
we want to
AI.
talk about the new in thing, why is not everybody driving using electric-based vehicles?
It's in the process. You just stick around and wait, and you'll eventually be riding one of those little
I
green.
still see people use push bikes. Occasionally, I still see people riding horses.
Here before long, you'll be driving one of those green little three-wheel cars. You know, don't worry, it's coming. Just relax. You'll, and it'll all be run off of freaking uh, electricity, and freaking it'll all have. You'll probably have a little methane in there too, but you won't have to touch the steering wheel or anything. It'll all be self-driven, and you'll be okay. Because that's what's cool today. Everybody's wanting it. You see what I mean? It's the end.
Everybody. So you're making a statement that you know what everybody wants, and everybody is just a single collector there. We are the Borg.
That's what's happening. Haven't you been hearing
That's
what I've been reading to you?
when people decide to go to the local grocery store, they aren't buying the things that they want. They're buying the things that they've been told.
Well, haven't you been
Right.
listening?
Actually, let me clarify. So, named entity recognition is not a technology. It's a
It's
general
a
concept,
concept.
a general process. It's a
Algorithm.
task. Uh, it can be implemented using transformer architecture. Right? They're not competing technologies. Um,
Oh,
so
concept. Well,
right,
like
yeah, it's a task. It's describing the thing that you need to do in order to process, in order to
the
understand.
methodology.
Yeah,
Methodology.
it's a
Much like
methodology. Exactly. That's right.
how
Yes, yes.
we how agile and scrum are different
Right,
methodology,
right.
methodologies.
It's a field, actually, is what you're getting at.
Or fail mythology, same thing.
Mhm,
It's a field.
mhm.
It's just been semantic. No.
Yeah.
It's. I mean, if well, I mean, you're the one that got all rowdy and shit. It's like, God, man, fucking English people are crazy.
I just take exception to
Well, I know you do, but that's what. This is excruciatingly painful
your sort of
for you.
everybody using it. There's no such thing as competing ideas.
Well, not when it comes to this, because see, this stuff is being integrated without your permission. Okay, you're basically gonna have to accept this, or you'll never be on a computer again. They'll shut you down.
If I'm not using a product, do they need my permission?
Well, dude, I'm just saying, if you are against this kind of stuff, then you're not gonna be able to do anything. I mean, you'll be able to be on Linux, I guess, and do all your cool Linuxy stuff, but that's about it. I mean, you're done. I mean,
Um,
that's just it.
how long how long has Homo sapiens been on this planet for? 40 billion years, or, well, 40 million years or something.
Then that's what you'll be doing. You'll be out in the woods, freaking hunting, freaking bear, like the woodsmen did back in the 1800s. Man, that's
Sounds good to
Hunting
me.
bears.
yeah. I
Yeah.
mean, you'll no longer have access to anything that's even partly good because, well, you'll have Linux, I guess, which I know you're big on Linux, but I mean that's sad. Okay, so
Whatever.
from what I'm seeing here, though, everything right here has to do with linking names, places, locations, and things of that nature together. Now, um, whenever you get on the phone and stuff like that, they
Ah,
the options.
these AI or these NLP systems are going to have
He's gone. He's gone blank.
the problem with messages. Have you seen?
Laggy.
How many messages have you seen? How many messages have you seen over the course of
You got to sit still, man.
the grammar and them? That's all.
Well, that's one thing that we're talking about with the ambiguity and the nuances and stuff like that. That's a big issue that they're having. With,
How many people have you seen write names all using all lowercase?
well, lowercase, they were mentioning that. That's what they're advancing in that stuff where they don't have to worry about that stuff anymore. They don't have to worry about capitalization or lowercase because they're analyzing it at such a freaking uh, intense freaking degree, I guess I could say. You know what I mean? Like it's minuscule. They're taking linguistics freaking and going like way farther than what we could ever do on our own. You know, it's insane and faster. So it's really messed up. Proper names and places. Okay. That's what they're doing, and that's what I'm saying. I mean, this stuff is going to be very, very dangerous. It really is. You can almost,
Potentially.
yeah. Because I mean, yeah, it's don't get me wrong. I understand what you're saying, Tan, but somebody is
What?
going to use this in
What?
the wrong way.
What am I saying?
Well, when you say it's how it's being used earlier, when
Mm-hmm.
somebody is going to use this in the wrong way. It's been proven over and over again with the internet that freaking you come up with a good idea and freaking they just screw it up. You know?
Again, it's just a methodology, right?
Yeah. Right.
It's just not the technology. So it's being implemented using transformer model. So you're just you're just talking about concept and methodology. It's
The field.
like if any technology out there that does language processing, they have to do this kind of stuff. So there's no getting around it, right?
Mm-hmm. Now, one thing that
If you want to use language processing technologies, not everybody may want to do that.
Yeah. Oh, I mean, in order to understand speech and written text, you have to do it. What do you mean? If you don't want to do it, then you fall behind.
well, I mean, he's in denial. He keeps like he keeps denying
Again,
that
language processing is something that we've been doing from the first day that we were able to communicate with our own species.
You keep denying the fact that you're going to have to be using this stuff, man. That's my whole point. Like you're going to be using this, and people are going to be tracking your location, your name, what you look like, your voice, what feeling and emotion you're in. They're going to know all of it.
If you're going to use a platform that does this, then of course you're going to have it. But if you don't use a platform that does this, then
okay, they're going to know what kind of freaking underwear you wear, dude. Okay. Yeah, because you're going to go to a grocery store, you're going to go to a shopping center, you're going to buy underwear, and guess what? Your receipt's going to be right there on the internet for everybody to see that you wear freaking underwear with Donald Duck on it.
I already know what underwear he wears.
Hey, robot. I mean,
I seen the meme.
wherever.
How's it going, guys?
It's going.
Have you figured out how to avoid the AI apocalypse?
Well, we first have to kind of get.
Mark still thinks computers aren't smart. Is that
well, he's a little bit.
Computers aren't smart. They're just tools. They're normal smarter than
Why do you think they call it a smartphone? Why do you think they call it a smartphone? Huh?
Because marketers have got too much imagination and time on their hands.
Okay, bad example, but no, yeah, it's getting close to scary time. We still have maybe a year or two up our sleeves.
Yeah.
But it's pretty exciting too, I must say. Like the amount of work I can get done now, and the things I can do now compared to before AI, it's just incredible. I think it's like it's pretty much the same kind of revolution as when the computer was invented. It's like up-leveling us again.
The amount of work that the machine does. And if the machine's doing all of the work for you...
but I'm getting credit for it, you know?
Okay. You're a middle manager, no more, no less.
Well, it's like having a personal assistant, you know?
Yeah. You get them to do all the work for you once you just...
It's laziness, I tell you. It's laziness. Mark Edworthy says you're lazy.
Well,
Look at that face.
uh,
He's like, shut up, Roger. Shut up.
I get to do more of the things I enjoy and less of the things I don't enjoy, which is good in my books.
So, do you know much about all this? Like what we were just talking about. Have you really gotten into?
I only heard little bits and pieces of it. You got into like a bit of the technical stuff on machine learning and how it works, right?
Do you know about NER? Named entity
NAR.
named entity recognition systems.
No, I don't. It's the
No,
first time I've heard that term.
no. What they do is they identify like your proper names, places, and it also goes through like the conversation that you have and determines the freaking structure and the context of everything. Statistical pattern
For what purpose?
for your language, for where you're at. For me, that's what I was talking about. I was like, this seems more of trying to identify a person's name with the freaking location that they're at. And
Oh yeah, it's gonna be abused. I mean, yeah, it's a lot of these dual purpose technologies, right? I mean, the amount of ways they can track us now already, it's um, it's very difficult to stay anonymous if even if you wanted to.
now,
But I saw. Did you see Elon Musk talking in Dubai, in Qatar about everyone's gonna have their own robot assistant, like R2D2 style, pretty soon? He reckons there'll be
Again,
10 billion robots on the planet
again,
in the next few years.
what did you say, Mark?
again, what is there with the what? Again, what is there with the everyone thing? Everyone will have this. Everyone will do this, and we'll all live in a grand utopia. Yeah. So the
Wow.
Amish are going to have robots now.
I saw
Yeah.
China just rolled out their first AI cops. Like, huge. It looks like a human, but it's like huge. And it's got 360 vision. It looks like something out of RoboCop, and that's where I don't want to go. I don't want those fucking robots roaming
And
around.
see, this is actually good that you mentioned China because this is what we need to remind Mark of. Okay, let's step out of our own freaking environment for a second, okay, and look at other people. Like people in China, the government of China is going to eat this shit up.
Oh
Okay,
yeah.
this is going to be straight up monitoring coming out of.
Well, they already had that, but now they've got actual enforcement, which is the next step, even fucking worse.
Yep,
And
and you
like
know,
that's just one small step away from robots getting out of control. You know what I mean? Like they already have the power to like crush us.
robots gone wild. I'm for that though. I actually want someday to own a sex slave, robot sex slave.
Yeah, but she can like snap your neck if she doesn't like you. If you
Well, as long as I treat her well.
well, treat her well and her owners. You know.
I got pissed off about Cherry 2000. You know,
Imagine if they found out you made a tweet 10 years ago that has diverging political views. Or
see, that was actually what we were talking about before. And when it comes to this technology, it's actually going to be able to detect the tone of your voice and the things that you're talking about.
oh, that's already they already could do that. I reckon for like 10 years. But it the other thing is, all these things will be interconnected as well. So like, and sharing data
You
most
are.
likely.
So one company's data is going to be automatically sent off to every. So you're living in some sort of communist sort of state now, in your because there won't be any companies because if they're all interconnected, then that just creates a monopoly.
I
Oh
mean,
yeah.
you don't really even have to say communist though, because like
Well,
England, where you're at, is a really good example. You guys are big on freaking monitoring everybody. It's like you got cameras set up in cities. I don't
yes,
even.
yes, but
No,
we've
for like
also got things like privacy regulations and data protection regulations, and companies can just, unless you officially agree to it, companies can't just pass the data off to another company.
What they gather in open spaces is it. You don't have protection in open spaces. I mean, everybody knows what open
What isn't
spaces
a closed online forum isn't an open space?
Well, what about the cameras that are monitoring you on the street when you're walking down the
Yeah,
street?
but that's controlled by governmental agencies or in
Oh, okay, and that's not a
Congo,
problem.
and there are
as long as you have the right type of
data
government, not
protection
a problem.
Yeah, that's not a
regulations.
problem at all, man. You know,
Maybe in your country it's just such a problem, but in this country we still got things like protection regulations
we
and
have
the rule of law.
For now,
we have
like
a rule of law called entrapment, and that means that freaking the
Yeah.
government is not allowed to entrap you in uh, charging you with a crime. So, like in your country, where it's okay for the police to freaking
I know
monitor
that's not true.
you,
How many times have the FBI used entrapment as a
well, that's kind
means
of
of?
my point. Is like laws are only so good. It's a matter of whether the government listens to them or not. How
right?
often does the
Well,
government break their own
Creating
laws?
loopholes.
Yeah, yeah.
well, you vote for the government.
You know, no, yeah, okay.
What
So
I
that
say.
means
So
At the end of
I
the day,
vote.
it's the responsibility of the public to uphold or to keep the government in check.
well,
So
that's true, but they took our guns. So what are we meant to do?
Yeah,
I think he's just
they
being a
use
little
guns to
bit.
fight, to enforce democracy for
I think
means.
I think he's just being a little bit too
I
naive.
don't think he believes his own rhetoric.
Oh, he does. Believe it or not, Mark Edworthy believes everything that's coming out of his mouth. Dude, trust me.
I don't know what scares me more, the AI takeover or Mark Edworthy's. What is it called?
He would have a terms of
Um,
agreement. Terms of service
I
would be on
I call it
everything.
common sense.
Mhm.
um, but I do think it's a good time to start playing with these AI tools and just getting your head around how to use them, how they work, stuff like that, because we are going into that era. It is going to be a new era. Like life is going to be totally different in 10 years time, not even. And I
Life
do
is
think
always
also it's
different
a good
every
time to
10 years.
invest actually in AI because like it's only the beginning phases of the boom, and it's gonna be like the .com boom but bigger.
And bigger
um,
and burst. Yeah.
yeah.
Well,
Um, After a boom comes the bust.
what
Well,
really gets me about this whole
I hope
conversation,
there's a bust eventually.
the whole thing about this conversation that really gets me is like when it comes to the linguistics part of it, it's like it's just completely amazing that you guys don't realize that everything we're discussing and everything that comes to this type of technology is related to linguistics. Okay? And
Mm.
there is no way around that when it comes to this kind of stuff. You know what I mean? Um, so it's like it might sound complex and you might get annoying having to listen to it. Well, sorry that you freaking got this headache when you was in college and you were supposed to be learning it there, and now that you're hearing it again, it kind of causes a really hard freaking headache on your head because you're having flashbacks from your college years. But that's what this is about. That's what it all comes down to. You know,
Why?
it all has to do with audio recognition. That's where all of this stuff starts out. Like we've been discussing, this technology. Okay,
Well, it's
and
not
hang
all
on.
audio,
So
right? That's just one
nobody.
aspect of it.
mhm.
It's video as well. It's text as well.
They
It's
actually started using
images.
the audio and coming up with ways of doing it with the video as well. Like whenever you have like facial recognition that is activated because of your voice. Okay, they turn around and they freaking have your voice talking.
Again, who are they?
The camera with the spies back behind it watching everything you say. Okay.
From a
Once
three-letter
once
US
they hear that
code.
voice, they pin in on your face. Bam, they got your face. So now they got your face, they got your voice, and it's all because you said a word in a
And what are
room.
they going to do? And what is this mysterious they going to do with the data?
They're gonna freaking sell you underwear, dude. Because
What if
because we
I
go
don't
back
buy their underwear?
because we go back to the point where you went to the freaking shopping. You went shopping and you bought a pair of underwear, and they have your receipt on record. So the moment they hear your voice, they freaking got your face, they got your voice. Now they can freaking send you freaking
I know most modern
advertisements
grocery
on underwear.
supermarkets and stuff have cameras in them anyway, and
Yeah, that's what I was about to say. That's what annoys me the most.
Well, your telephone, your
When
telephone.
you check out at a supermarket, they film your face, then they get your credit card, then they got your name, your credit card, and your face together. And they'll definitely keep that and sell that off at some point.
Again, depending on the company, depending on jurisdiction.
he just holds on to it, doesn't he? Like it's
So what kind of AI tools do you use, Roger?
for me, the only thing I mess around with, I've been experimenting with Chat GPT. I've been doing some of that because of the stuff Bob wanted me to play around with. So I started testing it out and everything, figuring out how it is all screwed up.
You know which one you'd love is 11 Labs. That's how you do the voice cloning and stuff like that. It's so trippy. Like
Now-
with like 30 seconds of voice, you can like fully clone someone's voice and make them say anything. That's how I did that one with you.
No,
So,
I do have.
So you want to? Your point is that you want to be on the end of a defamation case.
You're the only one that follows the law, Mark.
What are the point of? What's the real point of these things?
To make funny memes and shit.
Like the world centers on funny memes now.
No, the whole point of the voice cloning one, there's heaps of use cases. Like some people use it in music. Some people use it to read audio books and stuff. You know, like
Well, intellectual property.
sometimes you don't want to have to.
So
read a lot.
not only defamation, but intellectual property theft now as well.
Yeah.
Well, I mean,
And other people, they use it to pretend to be someone else, so they can, for example, get into their bank account, or you know.
I've been hearing.
So what are you saying? The only usage for this technology is to break the law.
No,
That's not what you were saying.
Making music isn't breaking the law, is it?
well, I mean, it all depends on which generation you come from. Like back in the day when freaking they were just coming out with rock and roll, dude. Teenagers used to get beaten with freaking bayonets and stuff, man, for trying to protest against them shutting down radio stations. So. So I could, and maybe like if we have people like Mark who are being staunch about it and put laws up against AI, we can have those days back where people are actually fighting against censorship, because I think freaking that people are too much into this. Let's bow down to the powers that be and say that it's okay for them to enforce this crap. You know. So maybe something will happen with artificial intelligence to where we have these people who speak up and say, "Oh, it's a horrible technology," and then they start trying to ban it, and then you'll start seeing people protest and say that they're
Well,
breaking.
no, the people won't even need to protest. You'll have your personal AI robot to go protest for you, right? And they'll all band together and like stand up to the government.
That reminds me of the old joke, the social justice lobby that that complains about.
See, they cut them off. That's that AI.
Yeah, they're DDoSing him.
That AI caught on to him getting ready to say something bad. They could tell by the tone of his voice.
I think his Neuralink glitched out. He's actually having a seizure. But
We
I see all these new laptops are now coming out with AI chips and shit. And that's not nice. I don't like them. I wouldn't give Microsoft that kind of power. They want to be able to screen capture your laptop every 15 seconds for convenience, you know.
now
Um,
you got a little bit of a background echo coming in behind you.
okay, maybe I'll turn my
Just to
mic
turn it
down.
down a little bit. I can barely hear it. It's not that bad. Well, you're turning it up now. So Mark had a fit and decided he was gonna run away. Here he comes again. We got him back up.
Can you hear me now?
Yeah, I can hear you.
Oh, okay.
We got some kind of weird echo coming into play right there.
Yeah, I'm back.
Hey, there it is. Man, see what happens when you get all excited and start moving around.
Don't move.
Freaking,
Can I?
he did it again. See, he
What
started.
was the
All right. All right.
Mhm. So before we go on with the conversation anymore, let me do another reading, to kind of give you an idea of what we've been talking about,
okay?
and then it'll be a long one, so you might get freaking bored.
What's the topic now?
Well, the topic has always been the same thing, but this is particularly machine translation. This is the
Machine
next one.
translation. Okay. Converting one language into another.
Yeah.
Okay.
So, machine translation is the field of natural language processing focused on automatically translating text to speech from one language to another. It is one of the most complex and transformative areas of artificial intelligence because it involves not only understanding the grammar and vocabulary of language. You got to echo real bad, dude. Do me a favor and mute out real quick, Mr. Robot.
My mic shouldn't be on. Was it on?
Yeah,
Okay.
yeah, it's on. You don't have it muted. Here, let me see real quick.
No, it was definitely muted. It's muted on my system.
Somebody's getting playback. Okay. Yeah, it's not you. Okay, so I have no clue what that's doing, where that's coming from. Is your computer giving feedback, Miss Robot or Mark?
No, nothing that I can detect. No, nothing there.
I'm wondering what's going on. Hold on, I'm gonna mute you out real quick. It's me, dude. What the hell is that doing? I have no actual reason All right. You unmute
Okay.
the robot. I had to hit refresh. I'm not quite sure why it's causing me to.
Is it better now, or is it still happening?
It's coming from my computer for some reason.
Okay. Are you hearing us with an echo, Mark, or no?
I can hear you fine.
Can you hear an echo?
No.
No, neither of us can hear an echo, so it's all good.
Okay, let
Worry
me
about
see.
your
Can you hear
phone.
me now?
Yeah, could hear you the whole time.
Okay. This is crazy. I have no clue what that's about.
Worry about doing post editing.
Okay, so the machine the machine translation is a field of natural language processes focusing on automatically translated text or speech. Um, I actually probably know where to go. Okay, yeah, it's Kick. Kick is the one that was doing it. Okay.
Machine translation has evolved significantly from early rule based approaches to modern statistical and neural methods.
Right.
Statistical machine translation represented an important achievement by learning translation models automatically from parallel corpora rather than relying on manually created rules. Early SMT models were word based, phrase based, without utilizing syntactic knowledge, which created challenges when translating between syntactically different languages.
hmm No, I'm also contextual, cultural, and idiomatic nuances also. Now, over the years, machine translation uh, has evolved through several phases, from rule-based systems to statistical approaches, and now to advanced neural network models. Now, have you ever done any research into the newer neural network models? Because we've had these conversations with me and Mark, but I don't think we have had them with you.
I only have like a rudimentary understanding about it. I haven't looked into specifically translation with neural nets now.
Mm-hmm. Now, see, this is particularly important for Mark if he wants to listen to it, but he's rebellious. He's a rebel. But like the earliest stages of machine translations were built using rule-based methods. Okay. Now, these rules relied on linguistic rules manually crafted by experts in both the source and target languages. Each rule specified how to translate specific grammatical structures and vocabulary. Now, while these systems worked well in high controlled environments or for narrow domains, they struggled with ambiguity, exceptions, and the variability of real world language use. And this goes back to what I was saying when I was talking about my using the narrators. Like I like to go in and use notebook narrator in notebooks for stuff that I don't want to read with complex language words and stuff. I will use a narrator, but then I have to go through and make sure that what I write sounds at least close to human. Um, and that's what they're discussing here, where they're actually starting to work on ambiguity and variability of real world language use, where it actually sounds
Mm-hmm.
like a human being talking. How many
Yeah,
videos have you listened to where you know damn well it's not a human?
yeah, no, it's getting really good, and you can set the variability on it as well, which is pretty cool.
Mm-hmm. Now, the next major development was statistical machine translation. Instead of relying on rules, these systems used large bilingual corpora to learn how words and phrases in one language corresponded with those in another. They calculated probabilities of translation based on frequency and concurrence. For example, if the English word dog frequently appeared alongside the French word chien in a parallel corpus, the model would learn to associate them. These systems were more adaptable than rule-based methods, but still had issues with fluency, especially with translating longer sentences or handling rare words and idioms. The most significant breakthrough came with the advent of neural machine translation. Neural machine translation uses deep learning, particularly recurrent neural networks, and later transformer based architectures to translate text more accurately and fluently. Now, these systems treat translation as a sequence to sequence task where an encoder processes the input sentence in the source language and a decoder generates the equivalent sentence in the target language. The use of attention mechanisms, especially in transformer models, allows the system to weigh the importance of each word in the input sentence when generating each word in the output sentence. This results in more coherent and contextually accurate translations, which for me that's actually a positive. You know what I mean? That has nothing to do with the people spying on your freaking location and stuff like that. That's actually something that could be constructive, in my opinion. You know, where
Constructed as in just being utilized.
yeah, being utilized as a way, like if I'm sitting here and I'm talking to somebody from China, you know, or freaking South Korea, you know, or some country where they're using a foreign language.
Google's had that for quite a while, right? Like Google Translate.
Well, I've never found anything that does that, to be honest.
Really?
Not,
Google Translate has one in the app, in the phone app. I used it a few times when I was traveling, and you literally speak in English, and the words come out in the other language. It's very interesting.
Yeah, but is the structure of the sentence correct in foreign language?
Yeah.
has it?
I mean, China, Mandarin, both Mandarin and Cantonese have different sentence structure than English.
Now that's the one issue they said that was a big problem with it. So when it comes to that, now
Okay. Yeah.
now modern machine translation models are trained on vast amounts of multilingual data and are capable of handling subtle linguistic differences. They can understand grammar, maintain agreement between subjects and verbs, and even preserve stylistic tone to a degree. Some systems, like those developed by large tech companies, are trained on hundreds of languages and can translate directly between pairs without relying on English as an intermediate step. A technique known as zero-shot translation. Now, machine translation is used in a wide range of applications, from real-time translation in video conferencing and live chats to automatic subtitling of videos, translations of websites, multilingual customer services, and international collaboration in research or business. It's also widely available through smartphone apps, allowing travelers to communicate across language barriers by scanning signs or speaking into a device. Despite its progress, machine translation still faces challenges. Language is inherently ambiguous and context dependent, so machines sometimes misinterpret idiomatic expressions, cultural references, or jokes. Morphologically rich languages, where words change form based on grammatical roles, can be difficult for systems trained on less structured language. Low resource languages, for which limited training data is available, also poses a problem since neural systems rely on large volumes of data for accuracy. So that means that these systems are also pulling in the data that's freaking coming from these low resource language devices. I'd almost bet. So they're getting all of it. So to address,
Well,
huh?
I noticed that voice recognition got a lot better after Google did that illegal trick where they turned all the mics on all their phones and they captured everyone's voices, and then they trained their AI or their voice models on all these different voices from all around the world, and it was like a big scandal at the time. But I don't know if anyone knows about that anymore. Like, they did that on their early phones, and yeah. And then I noticed after that, that's when
So,
Google Translate and all this came out.
so Google's Nexus or Pixel range. How many? What market share does Pixels and Nexuses have had?
Now Pixels, I know they've
You said
got.
you used the term everybody yet again, and not everybody owns a Pixel or a Nexus device.
I've got a Pixel, but I wiped
Well,
the
yeah,
operating
yeah, but you're
system off.
not everybody, aren't you?
Hmm.
What?
Again, you keep on using the term everybody.
Yes,
You are
he's calling
lumping
you out.
people into the same thing. Everybody.
I
I have no idea what you're saying, Mark.
Everybody must be spoken.
he's
Your,
he's fired
your
up.
connection is so
I,
bad,
I,
Mark.
I find your use of the term everybody to be extremely lazy.
Did I say everybody? I
Yeah,
meant like everybody
everybody.
that had an Android, of course.
Everybody that had an Android-based device was using a Pixel.
Yeah.
No,
See,
this is before Pixels. This is like way back in like early
So
2000s.
Nexus then, which was the previous
yeah,
brand
Nexus.
name.
That would probably be it. Right around the time Nexus was out or started out. Now to address these
Uses the one
issues,
technology.
to address
Stop
these
nitpicking,
issues,
Mark. Stop nitpicking.
let me finish. Researchers are exploring methods such as transfer learning, where knowledge gained from higher resource languages is used to improve performance in low resource ones. In multilingual modeling, where a single model is trained on multiple languages simultaneously to benefit from the shared linguistic structures. Human in the loop systems are also used in professional settings where machine translations provide a draft that is then refined by human translators. So you have things like transfer learning, and then you have human in the loop systems. Have you guys heard of those? Mm-hmm.
Okay.
So they're basically taking these models and they're transferring them to the uh, from the good freaking language structures down to the ones that have poor language structures. So that's kind of interesting right there.
The BBC's been doing this for for many decades now.
Well, it kind of reminds me of when we were talking about the cloud. You know what I mean, and how they're doing they're structuring this supposed cloud service. You know, I know you don't like talking about the cloud either.
The cloud, like there is a single cloud. What is it, big and fluffy and floats around in the sky?
And then Tan wonders why we have this freaking troll that just keeps haunting our every freaking move. It's because Mark Edway is an evil man. He's an evil English man. Mr.
An
Robot.
Englishman, common sense and logic.
Mr. Robot went silent. He doesn't know what to say. So, converting one language into another through machine translation involves a series of complex computational processes that attempt to replicate how humans understand, interpret, and restate meaning across linguistic boundaries. At the heart of this task is the idea of preserving the semantic meaning of the original text while rendering it in the syntax and vocabulary of the target language. Modern machine translation systems primarily use neural network architecture, especially sequence to sequence models with attention mechanisms and transformers to achieve this. So basically, they're going off of freaking chat GPT and everything, and they're doing sequence to sequence models and stuff like that in order to pull the data they need for this.
They are doing similar
You
things
mean
to chatty.
to analyze the data or to like predict?
Huh? You're
Sequence to sequence is like prediction, kind of like in a chat GPT large language model type thing, right?
hmm Now, when they talk about transformers, that's what they're talking about. They're talking about programs like Chat GPT and stuff of that nature, large data sets that are set up, and they use those to achieve it. At the heart of the task is the idea of preserving the semantic meaning of the original text. And in order to do that, they use sequence to sequence models with attention mechanisms and transformers to achieve it.
I wonder if Google Translate uses that.
Mm-hmm. Now, the process begins with encoding the input sentence from the source language. This is done by a component called the encoder, which takes the sentence word by word and converts each word into a vector or a numerical representation that captures its meaning and how it relates to the surrounding words. These vectors are not fixed definitions, but context-sensitive representations. For example, the word bank in riverbank and money bank will be represented differently depending on its surrounding words. This is an important feature because words can have multiple meanings depending on context. Once the sentence is encoded, the model enters the decoding phase. The decoder is responsible for generating the sentence in the target language. It starts with a special start token that signals the beginning of the output sequence. At each step, it predicts the most likely next word based on both the encoding input and the previously generated words. It continues this process until,
Again, the same thing that we've been doing for thousands of years.
right. Well, we do it in real life with our ears. You know what I'm saying? In our brains. And this goes back to what I was originally trying to tell you, is they're trying to simulate the human brain, okay, which is really freaking, that's really amazing from the stuff I've read. It's, I mean, they've They're really putting all out effort. They're actually wanting to like duplicate the process, how the brain actually works. You know, like plasticity and stuff like that. There's plasticity all over these freaking algorithms, like you wouldn't believe.
Well, plasticity is just the ability to change, right?
Right. That's the one thing that really sticks out in all of this. Now, it continues this process until it outputs a special end token or reaches a predefined length limit. The decoder relies on the context provided by the encoder, as well as its own internal state, which accumulates knowledge of what has been generated so far. One of the key innovations in neural machine translation is the attention mechanism. This allows the decoder to look back at different parts of the input sentence with varying degrees of focus while generating each word in the in the output. Without attention, early models had trouble translating long or complex sentences because they tried to compress all the input into a single vector. Attention helps solve this by enabling the decoder to draw dynamically from different parts of the input as needed. If the transformer-based models, which are now the standard in many commercial systems, no, in transformer-based models, which are now standard in many commercial systems, the encoding and decoding processes are built entirely from layers that use self-attention. This means that each word in the sentence can directly attend to every other word, allowing the model to capture relationships between words regardless of their distance from one another. Transformers do not rely on word order alone, but instead uses positional encoding to understand sequence. This gives them flexibility and power in understanding sentence structure, especially in languages where word order is highly variable. That kind of gets me to thinking about what we were just talking about. It's pretty intense. So they don't go off of word structure, or they don't rely on word order.
Well, they have like they keep track of syntax, or what do you call it, like context and stuff like that as well.
Mm-hmm. It gives them the flexibility and power in understanding sentence structure. That flexibility is what really stuck out to me.
Mm.
But retaining that, though, that goes back to the whole being able to retain this information too, because like whenever I was doing that stuff with ChatGPT, I noticed like ChatGPT's memory is just shit. You know what I mean? It doesn't retain very much information very long. So being able to, and they've actually built these up to be like that.
Yeah, it's designed that way, unfortunately. The AI that I use, Venice.ai, for privacy reasons, everything you put into the AI gets saved in your browser.
Why do you say unfortunately?
Say again?
Why do you say unfortunately? Why do you say unfortunately?
Well, I would like
Are you
the AI
saying-
to learn over time and get smarter, and based on what I say.
So,
Like ChatGPT, for example, they can just reset it every now and then.
what's the purpose of making this artificial intelligences smarter? What's your end
Because
goal?
then it becomes better at the tasks that are suited to you. You know, like you're into a specific niche topic, you do things a certain way. You want the AI to learn from your
So
collaboration
why
with it.
do anything if you don't get a machine to do it for you? Why? What's the old Sega Nevins song? Year 25, 25.
Not so much
Your
about getting
body
the
is
machine
left,
to do it
your
for you,
limbs are
Mark.
left, your beside your sides, and you're just being fed by a machine. Yeah. What's the point? What's your own purpose?
Well, I mean, getting fed
Well,
by a
to
machine
get
is not
shit
good.
done, you know, like
Hold
Can't
it's
on,
you do
about
that shit?
hold on, dude. No, getting fed
it's
by a
about
machine.
collaborating with the machines, not getting the machines to do everything for us. You
He
know,
said.
it's
He said. He said.
Collaborating with the machines, like they have got their own actual intelligence now
Well,
and
hold
their
on.
own
well,
sentience.
You just
now
said.
we're getting into the philosophical realms, Mark.
Yeah.
Well, you you are making this argument.
You had me hooked on the machine feeding me. Now, if freaking I can get a machine that will feed me, dude, hell yeah, I'm there. Okay, you, you.
Uh,
That's what I want. Feed me. You know what I mean?
Well, we could just get those ones
yeah,
that you're like in a
don't
vat
get
of
anything.
primordial
Electric.
ooze, and you just like get plugged
Yeah.
into the matrix
Dude,
for
just
good.
put a pair of freaking adult Pampers on me and freaking change my freaking diaper.
Again, what is the aim goal here?
That'll
Aim
definitely
goal.
happen. But anyway, we can talk about the philosophical implications at the end. Um,
As they always
anyway, it would
go.
be. Are we finished with? Are we going to start with the algorithms, machine
Now,
learning algorithms?
now, what I wasn't even done, dude. It's like,
I thought so. Mark so
We
rudely interrupted.
can.
Bunch of savages
I know,
over
I
there.
know, I know, I know. How long is the stream going to go on for? Because you're only on point two of a 6.7 point in, and it's already been coming
well,
up to 2 hours.
let me go ahead and do a straight reading, and then we'll be through with it, and you guys can say your final words. I'll just read it out, and then we can talk about it because this is actually I want to get through this part at least
Okay.
before. Okay, now during training, these models learn from large parallel corpora data sets containing aligned sentences in both the source and target languages. They adjust their internal weights to minimize the difference between their predicted translation and the correct one in the dataset. With enough examples, the model learns statistical patterns and linguistic rules implicitly without needing explicit grammar instructions. When translating a new sentence, the model uses what it has learned to infer the most likely translation. It must not only choose equivalent words, but also reorder them appropriately, account for gender and number agreements, adapt idioms, and maintain the overall tone and intent of the original. For example, the translation from English to French, it will learn that adjectives usually follow nouns and that verbs must agree in tense and number with the subject. It would also learn how to handle polite forms of address, such as distinguishing between to and vos. Despite their sophistication, machine translation systems are not infallible. They can make mistakes when handling ambiguous words, unusual syntax, or idiomatic expressions that don't translate literally. However, continual improvements in the model architecture, training, data, and fine tuning have made them increasingly reliable, especially for common language pairs. In essence, converting one language into another in machine translation involves representing the input sentence as a set of abstract numerical concepts, then decoding those concepts into new sentences into a new sentence that is grammatically and semantically appropriate in the target language. It is a process that mirrors human cognitive translation, though accomplished through statistical and mathematic computation rather than conscious thought. Accurately understanding and preserving sentence structure across language is one of the most critical and technically complex tasks in both machine translation and question answering systems. The structure of a sentence carries the relationship between subject, verbs, objects, modifiers, and clauses, relationships that are essential to conveying correct meaning. Each language has its own rules for sentence construction, word order, agreement, and syntax, and these can vary significantly. Therefore, any artificial intelligence system aiming to interpret, translate, or respond to human input must develop a deep understanding of these structural principles to avoid producing misleading or nonsensical outputs. In machine translation, preserving sentence structure means not only replacing words with their equivalents in another language, but also correctly reordering them to fit the target language's syntactic norms. For instance, English often follows a subject-verb-object order. The cat chased the mouse, whereas Japanese typically follows a subject-object-verb structure. A naive translation that does not account for this would result in an awkward or confusing sentence in Japanese. Similarly, languages like German or Arabic may separate auxiliary verbs and principles across long clauses, which must be correctly identified and reunited in translation. This requires the model to understand what each part of the sentence is doing, whether it's functioning as a subject, object, or modifier, and how these parts relate across both languages. Modern neural translation systems use attention mechanisms and large datasets to learn these relationships implicitly. However, when sentence structure is particularly complex, with embedded clauses, passive voice negation, or idiomatic expressions, the challenge becomes much greater. Misinterpreting the role of even a single word can lead to significant distortions of meaning. For example, consider the English sentence, "The man who the dog bit ran away." Understanding this requires recognizing that "who the dog bit" is a relative clause modifying the man, and that "run away" refers to the man, not the dog. Systems must parse these grammatical dependencies accordingly to maintain clarity and correctness in translation. In question answering systems, sentence structure plays an equally vital role. These systems must not only interpret the structure of the question, but also analyze the structure of possible answers. For a system to understand a question like "who did the president appoint to lead the agency," it needs to identify that the expected answer is a person, the object of the verb appoint, and that the president is the subject performing the action. If a sentence structure is misinterpreted, for instance, by thinking the agency is the object instead of the appointee, the answer retrieved will be incorrect. This structural awareness extends into how the system handles the documents or data it searches through to find an answer. In reading comprehension tasks, systems use natural language understanding models to represent both the query and the text in a way that captured not just vocabulary, but also syntactic and semantic relationships. Transformer-based models are particularly effective at this, using self-attention to examine how each word relates to others across a sentence or passage. This allows them to locate relevant phrases, understand pronoun references, resolve ambiguities, and identify the exact span of text that answers the question. A related challenge arises with paraphrasing and rephrasing. A question like, "What year did the Berlin Wall fall?" might be answered by a sentence stating the fall of the Berlin Wall occurred in 1989. The system must understand that fall of the Berlin Wall is synonymous with the Berlin Wall fell, and that occurred in 1989, directly answers what year. Achieving this kind of semantic alignment requires the system to analyze deep grammatical structures and match meaning across various expressions, which often differ considerably in form. To strengthen their ability, modern AI systems are trained on large corpora of parallel text and annotated data where structural relationships are labeled. They also rely on techniques like dependency parsing, which maps grammatical relationships between words in a sentence, such as which word is the subject or subject of a verb, and consistency parsing, which breaks down a sentence into nesting subphrases. These tools help the system decompose and understand complex sentence patterns, a necessary step for accurate information extraction, summarization, and translation. The preservation and accurate interpretation of sentence structures are foundational for any advanced language-based AI system. Without understanding how words function within a sentence and how those functions change across languages or contexts, systems would misinterpret meaning, mistranslate content, or fail to provide relevant answers. By combining linguistic theory with powerful computational models, today's systems are increasingly capable of managing these challenges, though the work of refining their precision continues. Understanding how different parts of a sentence relate to each other is essential for any language-based system, such as machine translation, question answering, or natural language understanding, because it allows the system to determine not just what each word means, but how each word functions in the sentence. Language is not just simply a collection of individual words. It's a structured system where meaning is created by the relationship among words and phrases. Failing to grasp these relationships often results in errors that can change the meaning entirely or produce irrelevant or misleading answers. Consider a sentence like "the doctor who the nurse consulted recommended surgery." A superficial scan of the sentence might incorrectly interpret the doctor as a person being consulted rather than the one making the recommendation. But a system that correctly understands syntactic structure would identify that "who the nurse consulted" is a relative clause modifying doctor, and that recommended surgery is the main action being attributed to the doctor. This level of understanding involves identifying roles such as subject, object, and verb, as well as recognizing which clauses describe which entity. In question answering systems, relational understanding is crucial to accurately map the question to the relevant information in a body of text. For example, if a user asks, "What did the scientist discover after the experiment failed?" and the system fails to associate the temporal clause "after the experiment failed" with the action of discovery, it might return a result relating to the experiment rather than the discovery. This would be a breakdown in understanding sentence structure. Proper interpretation requires understanding that "after the experiment failed" is a time-related modifier that applies to the main verb, discover, not a separate event or action. Even seemingly simple sentences can be misunderstood if the relationship is not clear. Take, for example, John gave his book to Mary because she needed it. The system must resolve pronouns in casual relationship. Who is she? What does it refer to? And what action is connected to what motivation? Misinterpreting this could result in the system associating the need with John or with the wrong object, especially in cases where gendered pronouns aren't available to help ambiguate. Moreover, in longer, more complex sentence subordinate clauses, passive voice, negation, and implied meaning all depend on correct mapping how parts of the system relate. In the sentence, "Despite the evidence being inconclusive, the jury found the defendant guilty," the phrase "despite the evidence being inconclusive" sets up a contrast to the jury's verdict. If a system fails to understand that contrast, it might assume the verdict was supported by strong evidence, leading to incorrect conclusions in a summarization or analysis task. Understanding sentence structure also involves recognizing dependencies between words. Dependency parsing, a method used in natural language processing, maps out how words are linked in a grammatical hierarchy. For example, in the sentence, "The cat under the table with the torn leg to the table," or "the cat." Humans resolve this based on plausibility and context, but computational systems must rely on syntax and statistical patterns unless specifically trained for such ambiguity. For systems trained on large language datasets, this kind of relationship awareness is learned through exposure to countless examples where words co-occur in certain ways and where syntactic dependencies are inferred. Attention mechanisms in transformer-based models help achieve this by allowing the system to weigh how strongly each word is connected to each other word in a sentence or phrase. This allows for a dynamic understanding of sentence structure beyond fixed rules. In practical terms, when a system understands sentence relationships properly, it can distinguish between similar sentences that mean different things. For example, "She saw the man with the telescope" could mean either she used the telescope to see the man or the man had a telescope. Resolving this kind of ambiguity requires contextual reasoning grounded in how the parts of the sentence relate. Correctly interpreting the structure of the sentence, how subjects, verbs, objects, modifiers, and clauses connect, is essential for any AI system that aims to understand language. Without this, systems risk delivering answers that are grammatically valid but semantically wrong, as language is often subtle, complex, and context dependent. Deep structural understanding remains a core requirement for precise and meaningful communication between humans and machines. So that is the end of this episode's reading, and we will do another one maybe later on, but that is it. So, do you guys have anything to say about that whole freaking reading?
I just want to say, see, this is a prime example, Mark, where if we had a clone of Roger's voice, we would have been done 10 minutes ago. You know, perfect use by AI.
I want to say that I did add tone to when I read that, which is something that most AI or narrators can't do. You got the real deal here, okay?
I would have just turned the jitter up a little bit. And
Roger, have you ever thought about becoming a supermarket or I don't know, a train announcer?
A train announcer.
Yeah, announcing trains coming
Well,
into the station.
I would have to be able to properly, say the words correctly. That's the problem. Misspelling is like, or like, I don't know how to even say that. Like, not even the misspelling. Like, if I try to read it and I can't say the word right.
what I got out of all that was
Certainly got a tone for it.
these machines, they basically do what our brains do just without even thinking about it.
They do a better job of it, and that's something I think that really makes Mark mad.
Well, you can't say all systems do a better job than
Faster, I should say.
brain.
They do it faster.
You can't even say that.
Wow.
Sure,
They
you
glitch
might
out
have-
a lot less than Mark's feed, that's for sure. Yeah, cool. But what apps do you know of that actually does this stuff?
more
Roger, do you know of
frameworks,
any?
more frameworks rather than applications. Might not be end user.
The only one I can think of is Google Translate. I don't know if that are like super advanced.
There is an open source project called Babelfish that's been around for good 30 years now, actually. Open source project.
Open source. What's it called?
Yeah, I think it's Babelfish. One or the other, I can't remember. Yeah,
Okay,
as
I'll
in
check it out.
hitchhikers. Yeah.
I'm waiting for a really good voice cloning open source software, that doesn't have any government regulations around.
What is your purpose?
Don't you mind your own business there, Mark?
Should
why I wanted to
law enforcement authorities be interested?
What I do on the privacy of my own network is no one else's business.
Well, it's me.
Until I upload it online.
Go down that route. I'm not going to go down that route at all.
Yeah, sorry.
Now, whenever we did the last show, we had a guy come on here, and he ended up following us on D Live, and his name was TV1 Brazil, I believe is who it was, and
What that appeared on the last? Well, that
the last
commented
episode.
on the last episode.
So
Didn't appear.
I wanted to give him a little bit of a shout out because that was pretty technical stuff. So that means he was smart enough to actually understand what was being said.
Well, I'm amazed that there's actually a few people in here still. If any of you guys are interested in AI and are looking to get into into some of the AI projects out there, I recommend checking out Tau or BitTensor. It's called. That's a really cool project that's going places where they're decentralizing the training data of AI, and you can set up your own subnets within their global network of AI training. And basically, this is
Sorry,
one of the
AI
good.
training in what form? Again, if you just using the generalized concept of AI, what do you mean AI?
In any kind of form, really, like they're sort of open sourcing the sharing of data sets that are able to be used to train AI on machine learning stuff. And
What training AI to what? Training. Hey, AI isn't a isn't a single technology. It's a concept. It's and you are conflating technologies or
okay, let me read to you what it is. BitTensor is a decentralized blockchain network designed to enhance the collaboration of artificial intelligence and machine learning models through a peer-to-peer ecosystem. The network uses unique consensus mechanism called proof of intelligence to reward participants based on the value of their contributions, ensuring continuous improvement and innovation. So rather than keeping it a closed source system like OpenAI does, pretty funny that they're called
we're talking
OpenAI.
about language processing there
Yeah.
specifically. So rather than AI language processing,
I said source of intelligence, right?
Proof of intelligence.
natural language processing is a subset of the overall AI concept.
But yeah, people are getting rich on this system pretty quickly. It's just in the early phases of booming. There's another one I just got involved with.
Are they actually?
He got
Some
Another
couple
brain
weeks ago. Are they actually getting rich, or are they getting some sort of crypto token?
okay. I've already
Yeah, they've got a crypto token, and then they use the crypto token to be able
they're not
to.
getting rich.
If anybody has a problem,
they're not physically getting rich.
Hold on.
So why did you say they're getting rich if they aren't actually physically getting rich?
Let me add this up first, real quick. If anybody out there is having problems with converting cryptocurrency over to cash, get in touch with me, and I can show them how to do it properly. It's not hard. I keep hearing this conversation where, oh, you're not able to do it. You can do it, and it's legal.
Depends on jurisdiction. Not everybody lives in your state or your country.
Cryptocurrency is legal. Now we can get into the whole debate.
Which jurisdictions?
We can get into the debate.
Would you conflate U.S. regulations with, let's say, Brazil?
Well, Brazil is a crooked freaking country.
I don't care. I'll sell you crypto.
What would you
Crypto for gold, crypto for cash.
My goodness.
As long as you do your
as long
yearly
as
account and
as long as
losing it.
remember, you receive money from or in your case, Australian sanctioned country could land you in jail. could
And
lend
we
me.
won't tell the police
you.
about that little bit of cryptocurrency I sold you last week, Mark.
Oh,
Please.
yeah, he's got quiet. He started grinning.
Yeah, because he's just taking the piss.
He
I won't
started-
tell him you were on the dark web buying weed, trying to score.
God's sake.
It's weird that you mentioned that because that's an issue I do want to actually go on and discuss somewhere, maybe on Untethered. But like
Yeah.
this whole idea of the dark web, you know what I mean? Like I actually got into the history on where this word came from, and it's a complete load of crap,
Let me guess. Apple executives.
dude. I'm gonna tell you right
Apple
now.
marketing
Tell you right now,
executives.
this fits in perfectly with my whole untethered thing with the internet is a scam. Okay, when you start learning about the true history of the quote unquote dark web, dude, you'll start understanding how freaking the internet's been manipulated and you've been lied to about what's really going on when it comes to the internet. It's
The
just
internet or the web?
it's
Well, give him a plug. Tell him where to find you with the Untethered. We'll
well,
do that.
you can find me here tomorrow.
Is it? It's not on this channel though, is
Oh,
it?
wait, no. On Rumble, you have to go to the Praetorian, and I only put freaking the censored version of Untethered on YouTube, which usually takes me about a week because Mr. Robot says a lot of really awful shit on there.
Well, you're not meant to put it on YouTube. That's the thing.
Well, I mean, I have to. I can't resist. You know what I'm saying? So what I do is I go through and I edit out all the horrible stuff that you would possibly get me in trouble with, and then I put it on there. But you can find it on the Praetorian on YouTube, and besides that, you can just find it on Kick, Twitch, and DLive. I mean, just under my regular streams, daily streams, they'll come on. So, but it's really
So-
good.
Yeah, that's probably my favorite show, actually.
Now, this next one, me and Mark was discussing it on Untethered. We're going to do, well, the internet's a scam, dude.
The
That's gonna,
second part.
the second.
Yeah, we did the first part, 3 weeks ago?
Mm-hmm. And we start. Yep. And we start.
So we haven't spoken about Tor yet, have we?
Well, first we want to get into the hackers. We want to talk about the hackers that were.
The OG hackers, and we'll work our way up to the modern day hackers.
Yeah, well, we've already
The
done.
frackers. Not hackers. Again, I disagree with you on your
Freakers.
usage of the term hacker.
So the hacker. See, there we go. You know, I can understand now why people hate you.
You can understand what?
Why people hate you, dude. You're like you're always like pissy about shit. We're getting
People love
stuff because of freaking you, man. They're
I
like,
hate him. I hate his guts. Bloody
no,
English.
yeah, you are.
I'm just joking, man.
People are getting on freaking Dan's freaking posts and like talking shit and everything because Mark Edworthy gets on there being critical about everything, you know. This one guy.
He's on
somebody else
token.
today.
Well, I mean, it's just, you know, if you can't what is it? You can't take the heat, stay out of the kitchen. You know what I mean? If you can't roll with the big dogs, freaking go sit on the porch.
Indeed, Roger. Indeed.
So I'm good for it. I can hang it out. I'm cool with it. It's just that's my way of speaking out against all those trolls that are attacking our innocent Oriental dude, Tan Hai Tran.
I'm cool with a little bit of pushback, but it's got to go somewhere, not just for the sake of disrupting the conversation like usual.
Exactly. I don't know which one I hate the worst, the freaking trolls or the people trying to get you to freaking buy views and stuff on websites.
I delete that comment straight away.
I
It's all
ban
bots and stuff for sure.
them. They just irritate the hell out of me. So before we go, you guys want to give your information? We'll start with the robot.
If you guys are into some trippy music, type into Rumble Hacker Radio, and yeah, come check out my tunes. And we have like little live parties every now and then. So give me a follow, and you can join in with the party sometimes. So we'll leave it at that. I'll see you guys next time.
And how about you, Mark?
Like both of you, on Minds, Minds.com being my primary sort of media platform. So yes, Minds.com is actually,
You're gonna have to say that again. You started breaking up.
okay. I'm on Minds.com under the username Medworthy.
Okay, there you go. And like Mark said, that you can find me on minds.com at Roger_Hansen. You can also, well, actually, I'm on X too. I forgot to even check to see what that is. I'm on X as Roger Hansen at ROGLOL1973. You can find me there. As well as that, you can find me on Elements at Live with Roger Hansen. Just I don't even know how to do the link on that, how that would come out, but um, those are the way you can get in contact with me. I'm also streaming on Rumble, YouTube, Twitch, DLive, Kick, and X. You can watch our shows on those at any time. With that being said, man, I'd like to say if you guys like what you saw, please like, subscribe, share, make comments. Make comments. I'm dead serious. And if you
Oh, if you get confused on how to find us, just drop a comment and we will
right,
get back to you.
good call. Make a comment and we'll get in touch with the person that you need to hook up with and maybe connect with. Mr. Robot needs a girlfriend too. Just putting it out there.
Yeah, it's got to be a robot girlfriend.
And he's from
Otherwise, we
Australia.
won't match.
Just so you ladies know, he's from Australia. He's got that Australian background. You know how those Australian boys are. So
These guys think they know me. They don't know anything about me, where I am, what I do.
so with that being said, I hope you guys have a good morning, evening, afternoon, whatever time it is in your neck of the woods, and we will bring it into this. Goodbye.